Hello everyone, welcome to Horizon Summer School. Today the session is on Python for physics and astronomy. So one thing I wanted to make clear is that this is not a programming session. Today we'll be learning things about Python and how it is, just the basic functionalities of Python and how we can use them in physics and astronomy. Uh, I will share my screen now. Let me know if you cannot see it. Is it visible? Vatsal, can you tell me?
It is visible.
Yes.
Okay, okay, great. So Python is a programming language. If you have experience with any programming languages till now, you will find at least the first part of the session very easy. Even if you don't, Python is one of the easiest languages to learn. So you shouldn't have too much of a hard time learning it. Okay, so the most basic thing in every single language we always learn is printing hello world. So in Python, by printing we mean giving it as an output. So in Python, that is very simple. We just use the print word, open brackets, and then we put in whatever we want to write. For this tutorial, we are using something called a Jupyter Notebook. So a Jupyter Notebook, basically, it provides us with these cells, cells of code, cells of text with markdown, LaTeX, and other ways to put down interesting text and different symbols. And we can get output in real time. For example, I set count equal to 0. So this is a variable. One of the most important things in a language in programming is variables. So variables are essentially just names given to data where we can store some information. For example, if I want to store the number 0, I want to store the count of something. Currently, I have nothing of it. So I stored 0 in count. So this count is some location in our computer's memory where the value 0 is stored. And when I print count, I get the answer 0. So this is some Python code. Now I can run it here and I will immediately get some output here. Now, variables don't just store numbers, they can also store strings. A string is basically a sequence of characters. For example, a name is a sequence of P-E-T-E-R. So Peter is a string. And in a similar way, I can print that as well. To assign variables, I can also use this kind of syntax. I can say age comma name equal to 30 comma Peter, and they are assigned to the variables respectively. So if I print this, I will get 30 Peter. One more important thing in any language is taking input from the user, right? So in Python, that's also really easy. You just say input of, and then you say what prompt you want to give. So if I run this, I'll get a prompt saying enter age. Now if I put in 18, now it's asking me to enter name. Now I'll put in my name. Now it is print. It stored both of them in age and name. Now it's printing them 18 other. So this is all about variables. Now the way in maths we have some basic operators. We have the same operators in Python as well, because the point of computers is to do calculation to some extent, right? So we have the basic plus operator. So we take the values in x and y, we add them, and we store it in z. So if I run this, now x and y have 5 and 2 stored in them. Now if I run this, z will have 7 stored in them. Right? If I run it, it prints 7. Similarly, x minus y, x into y. We use the asterisk symbol here. Usually while writing, we use the x symbol, but x is already an alphabet. So asterisk has been reserved for multiplication. The slash has been reserved for division. There's something called the double slash. This means floor division. So x by y is basically the quotient when you divide x by y. So 5 by 2, the quotient will be 2, and this modulus is for the remainder. So the remainder will be 1. This is for power. X raised to y is written this way. These are just basic operators. If you ever forget any of these, you can just Google how to do this in Python. And the Python community is really good. There is a lot of Python resources online, and you can always get whatever you want. Okay, so we can do these operations inside print statements, as you can see, and we can even do any more complicated operations inside print statements. So if we take x plus y into a by b, now here you can look at the precedence order. This follows BODMAS again. So first we will do y into a. BODMAS actually does division first, but here division and multiplication order doesn't matter. So you can also do a by b first, and then y into a, then you add x to it. Now this int of this the int function, we'll look at it a little bit later. So if I run this, you can see what is happening. Okay, there is another shorthand notation. In programming, a lot of times we just want to increment the value of a variable by 1. So this is the normal syntax we will use. We will take the value I, we will add 1 to it, and then we will store this new value into I. This is what this means. So if you see this, this seems like an equation in maths, but in programming, the single equal to sign, this sign means it's an assignment. You're taking the thing on the right and you're putting it in the left. An equation in programming is different. In that, you use a double equal to, where it is implying that the left side is equal to the right side. So this was a confusion I had in the starting when I learned programming as well. You will get used to it. Single and double equal to. So the shorthand notation for this that has been made so that this can be done faster is I plus equal to 1. So you can say I equal to 0. Now this will set I equal to 0 plus 1. Now the new value of I will be 1. So if I print it, I'll get 1 first. Now if this thing increments I again. So now I will have 2. Any questions till now? Fine, I'm assuming no questions. Vatsal, please tell me if there's any questions in the chat.
Yeah, I'll do that.
Thanks. Okay, so data types. So as we had seen before, we looked at 2 data types. One of them was the integer, for example, storing 30, storing 0, storing 30.
1 second. Someone had raised their hand. Do you have a question? Please unmute him. I can go ahead.
If you have a question, just say it out
Yes,
or put it
please.
in the chat. No need to raise your hand. You can interrupt
I was
me at any
asking
time.
whether all the operators work like the plus one did.
Sorry?
Like in the assignment, you have written I plus is equals to 1, meaning I is incremented by 1. So
Yes.
if I substitute plus with multiply, minus, or divide, will it function the same?
Yes, it works. It works the same way.
Okay.
Almost all operators will work the same way. I can show it to you. I can do I multiply equal to 2 and I minus equal to 1. So the value was 2, right? So 2 into 2 is 4 and 4 minus 1 is 3. So if I print I, I'll get 3. Okay. So we looked at a few types of data. We looked at the integer and the string. There are a lot more types of data. There are a lot more data types in Python, which are widely used. So integer, as we had seen before, any number with no decimal parts from minus infinity to infinity. A float can store integers, decimal numbers as well. So the way this is stored internally is a bit complicated. If you are really interested, you can look into it. This is basically just converted to binary and stored. A string is basically text. So any sequence of characters. So I is a character, n is a character. So any sequence of characters is a string. So the strings also have a plus operator. Like the way integers have a plus operator, strings also have a plus operator, but it is something slightly different. So if you use plus between 2 strings, so first name is a string, your name is a string. So what it does is it concatenates them. It joins them directly without any spaces between them. So I've done this. So it printed your name is, then it concatenated Peter to it, then concatenated a space to it, and then malan to it. Does that make sense? Fine. Sometimes we want to convert data from one type to another type. This is called typecasting. So one of the biggest examples in Python where we use this is when we give input to the program reads it as a string always. Because the program by reading does not know whether I want the input to be a integer, whether I want it to be a float, or whether I want it to be a string. The program does not know. So it always takes it as a string. So if I put anything for x here and I put anything for y here, x plus y, this will do the string operation of plus and will concatenate them. So I will run this. If I put x equal to 5 and y equal to 6, it took the strings 5 and 6 and it concatenated them to give me 56. But I wanted them as integers, right? So the way I typecast, I convert it to an integer type is I use this function. I put int open bracket and put whatever I want inside. So here x and y, they will be stored as integers now. And now if I run this again, if I put 5 and if I put 6, I'll get the correct answer, which is 11. Similarly, I can do float of. So if I put 5 here, if I put 6 here, now it will read 6 as a float. So it will read it as 6.0 and it will add them and give me 11.0. Okay. One more basic data type. This is also once again present in almost every language. Is called a list. A list is a variable which stores multiple things inside it. So instead of storing these in separate variables, score 1, score 2, score 3, score 4, I just make a variable called scores and I have an array. I have multiple of these inside it. So the way I separate them is using a comma. So this square bracket is used to represent the start of a list. Comma is the separator between two consecutive elements, and this close bracket is the ending of the list. So the way I access the elements inside is using their index. So the index is the position at which they are. Now, at all points in programming, indexing always starts with 0. So 78 is the 0th value in this list. 67 is the first value. 69 is the second value. So if I print scores of 0, this is how I access the 0th value. So I forgot to run this. I will get 78. Now another way to access values inside a list is to slice the list. So this syntax represents that I will take the values from the 0th index, second index to the 4th index. So this is 0, 1, this is 2, 3, and the 4th is excluded. In Python, usually you exclude the upper limit. So if I run this, I should get 69,5. That's what I got. Another function that works on lists is delete. So if I say delete scores of 4, so it will delete the 4th element from this variable. So 0, 1, 2, 3, 4. So 0 will be deleted. So this is just the same list, but with 0 deleted. 4th value got deleted. All right. Now another data type similar to the list is the tuple. So a tuple, instead of the square brackets, it uses round brackets. But you cannot change the values inside a tuple. So what I could do in a list is I can say scores of 0 is equal to 100. Now if I print scores, the 0th value would have changed. I changed it to 100. But in a tuple, you cannot change that value. So the reason for this kind of thing is that the programmer by mistake should not change it. If I know that this, for example, this is a list of months, this is something fixed. This is not something that should change during the program. So if I put it in a tuple, there is no way the programmer can by mistake change anything in it. That is the purpose of a tuple. So in the same way, I can access inner elements of a tuple, but I cannot do something like this. This will give an error. Once again, the plus operator works on lists as well. So if I have two lists and I put a plus operator between them, it will just create a bigger list. One interesting thing, the multiply operator also works on strings and lists. Can anyone tell me how it would work?
It will just append the two lists.
Yes, it just makes copies of the list.
It'll replicate
Yes.
the numbers.
Yes, just makes those many copies of the list and concatenates them. So it is the same as repeated addition in lists as well. It concatenates them over here as well. Okay, so the same thing works for tuples as well. The same thing works for strings also. Now we come to the dictionary. So a dictionary, also known as a map in some other languages, basically stores pairs of values. So it stores key value pairs. So this is a key, and this is a value. Now they're separated by a comma. Key value. Key value. So the value can be of any data type here, but the key can only be a data type which cannot be changed. For example, an integer, a tuple, a string. So to access the elements here, I put the variable name, and in the box brackets I put the key. So I put marks of 67, I will get 95. If I put marks of maths, I will get 98. So the key is maths and the value is 98. So this is just a convenient way to store things. This is less efficient than the list and the tuple for storing, because you have to, the way you access it is different. But this is a very convenient way to store if you have, for example, marks in a subject. So I can just get the maths marks in this way. This is how you initialize an empty dictionary. Similar things are there for empty lists as well. This is an empty list and this is an empty tuple. You might notice that you need a comma in the tuple. This is because if you don't put a comma, and open and close brackets don't mean anything on their own. One interesting thing. So if you want to get the type of some variable, if you created some variable and you forgot its type, what you can do is you can write down type of the variable and will print out. So for example, it was dict here. If I put type of 5, it says int. Now if I have type of box 5, this will be
List.
Yes, list. And if I put type of this bracket 5, yes. So everyone thinks it will be a tuple, but the problem is it's not a tuple, it's int. If I just put 5 in a bracket, it's not a tuple, right? It's just a single value. So to signify that it's a tuple, I need to put a comma after it. If I put 5, 6, yes, that is a perfectly good tuple. But if I have a single value, I need to put a comma here, otherwise the language does not recognize it as a tuple. Okay, great. I can add things to the dictionary using this syntax. So I can put in a new key, I can set its value, and the value will be here. And if I print the whole dictionary, it prints like this. And then I can set values, more values inside. So this is all about data types. Any major questions till now? Any questions?
In tuple, if we have more than one variable, like 5, 6, 7, 8 we have put, then after last variable, do we have to put a comma also?
No, no, no. The comma thing is only if you have a single value.
Okay.
Even if you put a comma, it's not a problem. It's still a tuple. But even if you don't put it, it works. The ambiguity is only when there is just a single value inside.
Adut, there is one question in the chat.
Yes.
It says that when my list is multiplied by 5, the output was a random arrangement of 1 or 2, or was it the order of the output?
No, no, it's the same list. You make 5 copies of it and you concatenate them. It's not a random arrangement. If you have 1, 2, 3, you multiply it with 3. So it will be 1, 2, 3, 1, 2, 3, 1, 2, 3.
When two tuples are concatenated, will we get a tuple or a list?
A tuple. Also, you cannot concatenate a tuple with a list. There are different data types.
In a dictionary, the key, which type of data types can be used for key and which can be used for values?
Yes. Okay, I'll cover that quickly. So there are two types of data. There's mutable data and there is immutable data. So mutable data type is one which can be changed. That does not mean it can be changed and replaced. For example, in a list. So in a list, you can easily do a list of 0 is equal to 5 and you can replace the value at 5. So it can be changed, right? Similarly, in a dictionary, you can do a dict of 7 is equal to A and the value will be changed. So these are mutable data types. Now, an immutable data type is something like an int. So in int, if you do int x is equal to 5, you're replacing the value inside x to be 5. You're not changing it. It is a weird distinction, but it is significant here. So similarly, a tuple, you cannot change the values inside it. You can only change the whole tuple itself. The same thing is there with a string. So only immutable data types can be used as keys. Basically, the key shouldn't keep changing. Once you have a key, the key should be fixed, right? So the integer, tuple, string, also the float. Float can also be used as a key. Even the bool can be used. I haven't covered the bool, but it can also be used. Does that clear your doubt? Okay, no more questions, I guess. If you have any questions, you can stop me at any time. I don't mind. Okay. Fine. So next we have actual programming. So one of the most important features of programming is conditionals. So I want to do something only if a given condition is true. For example, if I take an n number as an input, I want to say correct if it is greater than 6. I want to say learn counting again if it is equal to 6. And I want to say incorrect otherwise. So the way we accomplish this in Python is using if, and else statements. So first of all, let's go through the conditions. What kind of conditions do we have? So a condition is something which returns a Boolean value. I haven't covered what a Boolean is now. So if I say x is equal to true, the true T has to be capital. The type of x is a Boolean. So a Boolean variable can contain only two types of values, either true or false. There are only two possibilities. These are the only possible bool values. So these are logical statements. 5 equal to 5. This is the equation thing I talked about before. I talked about single equal to meaning assignment and double equal to meaning equation. So if I write down an equation or an inequation, the value that I get from it is always a Boolean. If I say print, okay, does it? Oh, it's already there. So if I say print 5 equal to 5. Now 5 equal to 5, the equation 5 equal to 5 is true. So it will print true. The equation 5 less than 5, the inequation actually, is false. So it will print false. 5 less than 9 is true, so it will print true. 5 less than equal to 5 is true, it will print true. So I can see, I think I can understand what is going on over here. So when I put an a condition, basically a Boolean value in front of an if, this next statement, the one after the colon, will execute only if this is true. So let me try this out. I'll run this. I'll put in the value 7. Now this thing is n will store 7. 7 greater than 6 is true. So it will print correct and it will go to the end. It will go to after the else statement. So just printed correct and stopped. If I run this and I put the value exactly equal to 6, let's go through what happens. So it will check is 6 greater than 6? That is false. So it will go to the else if. In Python we write it as elif. This is a short form for else if. Now we check, is 6 equal to 6? Yes. So it prints, then counting again. Now if I put in a value of 4, it checks this condition. Is 4 greater than 6? That is not correct. Is 4 equal to 6? That is also not correct. Else. So if there is if none of the above statements were correct, it goes to the else statement. It prints incorrect. Yes, someone has a question.
How does the single is equal to value is assigned versus the double is equal to value in the above example?
Sorry, I didn't understand.
As you in the first condition you have written print 5 double is equals to 5, then it is showing true. But what would have happened if you have printed 5 is equals to 5? How is that different?
Okay, so a double equal to 5. When you have a double equal to, it is a operator which checks whether the left side is equal to the right side, and it returns true or false. When you have a single equal to, it assigns the value on the right side to the left side. They are completely different things. So I will go through. I will say int x is equal to 3. Let's say x equal to 3. X is not an integer, right? Now if I say x is equal to 5. So it will tell me false. 3 is not equal to 5, right? Now if I say x is equal to 5, and now if I print x, here, so x is equal to 3. It says no, 3 is not equal to 5, so false. Now if I print x, the value of x is still 3. Now if I do x is equal to 5, the value of 5 got stored inside x. There is no comparison happening here. This is the assignment. The 5 is assigned to x. If I do 5 is equal to 5, it will throw an error. Wait, if I do 5 equal to 5, it will throw an error. Because you cannot assign a value to 5. 5 is a fixed value. The assignment does not work. Was that clear?
Yeah, it's clear. Thank you.
Okay, great.
Hello, sir.
Yes.
Can we add in many else if statement before the last one else? Or
yes, you can put as many else ifs as you want, and having the else is not compulsory.
Okay. So
you can have
what will happen if there's no else there?
If there's no else there and none of the conditions are satisfied, nothing will happen.
Okay, so no output will be given.
I mean,
it will go.
It will come over here. It will come to this line. It won't execute any of these if there is no else.
Okay. Thank you, sir.
Okay, we are getting great notes. Fine. One more very important thing that programming languages have are loops. So loops give us the ability to do the same thing many times without writing the code for it many times. So for example, if I want to print every value in this score list, so what I can do is I can put down any name here. I can put A, P, P. I can put down Apple here. So for Apple in scores, I can say print Apple. I'll comment out the rest for now. So if I run this, it will just print out every single value inside. Notice this is scores of 2 to 5. Now we had gone through this before. 2 to 5 is giving us this part. I'll just remove this to avoid confusion. For apple in scores, print apple. So this basically means you go through every value of score one by one, and then you assign it to apple. And then you print it. So the main syntax for this is for variable name in iterable. So anything we can iterate over. Now this can be a list, this can be a tuple. If you want to iterate over just a series of numbers, so one way to do that is you put range of 5. So now to iterate over numbers from 0 to 5, excluding 5. The range is an interesting function. I don't think we analyze it properly this time, but if you want to go from, for example, 1 to 100, and you want to take steps of 5. So I'll get this as 1, 6, 7. Now these are steps of 5, and it goes from 1 up to 100. Okay. Now let's try this. Uncomment out. So in Python, if you want a line to not run, you put a hash before it. Now this is called a comment. So if I run this, if the number is equal to 50, if the number is greater than equal to 50, you says, hey, it is a 50. Otherwise, you say not a 50. So we don't have any 50s here. Wait, I'll go through this then. Put in a 50 here. So the numbers that are greater than 50 print a 50, and if it's not greater than 50, it prints not a 50. So we can increase the size of score here. We can change the values inside, but the size of our code will remain the same. Otherwise, if you wanted to print every value, you would have, without a loop, you would have to say print scores of 0, print scores of 1, print scores of 2. That code will keep increasing. The size of that code will keep increasing as your list size increases. But now, using just a few lines, I'm able to go over the list. There is also something called while loops and do while loops. You can look into those if you have time later. But everything that can be done with one loop can be done with the other loop as well. Okay. Functions. So functions are basically small blocks of code which can be called again and again. For example, the syntax for defining a function is you write def, which is short for define, function name, and the inputs to the function. Then you do whatever you want to do inside the function, and then you can return a value. So for example, this function is there, count 50s. So I'll get a list here of scores. I will set the values of 50s to 0. 50s, I'm making a new variable, setting its value to 0. Now I'm having a for loop, which goes over the scores, takes every single value in it, and if it is greater than 50, this thing increases by 1. So essentially, it just counts the total number of numbers greater than 50 in this list. Does that make sense? And then it returns this value. So in the next slide, we will see, in the next cell, we will see what return means. But any questions till now? Okay, I think no questions. Okay, so I'll create some data. I'll create a dictionary called score stats. Now here I have Dhoni's score. Dhoni scored the run 67 in one match, 32 in one match, and 183 in one match. Similarly, I have Virat scores and I have Rohit scores. Notice that over here, Dhoni is a key, and the value corresponding to that key is this list. So if I say score stats of Dhoni, I will get this list. Is that fine? Same thing with Virat and Rohit. Now, when I say count 50s of score stats of Dhoni, this thing is sent as input to count 50s. So when this is sent as input to count 50s, basically it will count the number of things greater than 50 inside. So that is 2, right? 67. So first I will have score equal to 67. Score is greater than 50, right? So 50s will be equal to 1 now. Now 32 is not greater, so no change. 183 is greater than 50, so 50s will increase by 1 more. So I'll get 2 now. So if I print count 50s of score starts of Dhoni, I will get 2. Virat the same way. All 3 scores are greater than 50, so the answer is 3. And Rohit's 2 of his scores are greater than 50, so it will print 2. So think, if you had to do this without using functions, you will have to write the same code 3 times, again and again over here, and then you will have to print. But this made our code so much shorter. And now we can use this function as many times as we want. That is the power of functions. You give it an input, and it gives you an output. This return value is what comes out when you say x is equal to this. So this will be the value that x stores. To get that point across, I'll do this. X is equal to print x. So the count 50s of score starts only. The returned value 2 gets stored inside x. And now when I print x, it prints 2. Now, once again, you can see there was some repetition of code here. I was writing the same thing again and again while changing only a small thing. So now I can use a for loop to automate even that. So if I say for pair in score starts, I told you what happens when this thing is a list, when this thing is a tuple. But when it is a dictionary, then this thing gets the values of the keys in the dictionary. So player will first take the value of Dhoni and it will print Dhoni's number of 50s, then Virat, number of. So all of this got converted into such a small code. Any questions till now? This is the basics of Python. This is everything you need to know about the language, and now you can start doing everything. Now, any questions here? And I'll go to the next part. Otherwise.
आगे बढ़ो.
Okay, I think there are no questions. Anyways, I'll share this whole notebook in the Teams later, so you can go through it at your own leisure, and you can ask in the Teams itself if you have any questions. Fine. Now, the interesting part. Okay. First of all, file handling. When you are doing any computation, the chances are that the data that you want to work on is stored inside a file. Programming languages give us a way to open files, read the data inside, write more data inside files. So in Python, file handling is done using a bunch of functions. One of them is called open. So you have a file name. This is basically the path of the file. Right now, the file is in the same directory as my notebook. That's why I don't need to give the full path. Otherwise, you might have to give the full path of the file. So you say file name is equal to this thing, file1.txt, and file equal to open of file name. So when you open it, basically you get a file object. Now this does not contain the data of the file just yet. This consists of a way to read the data. This is not the data yet. And this R represents that I am in read-only mode. When I open a file in read-only mode, I cannot make changes to it by mistake. Similarly, I have write mode, I have append mode, I have read and write mode. Similarly, I have text mode and binary mode. Right now, this is a text file, and by default, it's always in text mode. I'm opening it in read mode. Fine. Okay, so once I have opened the file, I can read it using these functions: the read function, readlines function, readline function. So the read function reads the whole file as a single string, Read line will just read the line I'm currently on, and read lines will read all the lines and give it as a list of lines. For example, if I do file.readline of 7. Now, first I'll show you the file. The file is just hello everyone, hi. Now, if I do file.readline of 7, so it will read the current line, the first 7 characters. So HELLO space E. These are 7 characters, so it read the first 7 characters. Now you can imagine the cursor of the reading of the file reading object is after the E. Now if I do file.readlines, it will start reading from after the E and it will keep reading and it will give me a list. This is the finished version of the first line and this is the next line. Any questions till now in file reading?
The file object that was there, what is it like? What is the data type, and does it is it the txt file?
Okay, Aaron. So the file is basically input or output text IO wrapper. Now this is something complicated. If you want to really get into what this is, we will have to go to object-oriented programming. Now we aren't going to go deep into that today. Basically, this file gives us ways to read a file. This is an object which basically you can think of it as the cursor. So the file has been opened and this cursor is there inside the file. So when I say read line 7, so this cursor moves ahead by 7 and tells me what it has read. This is not the data of the file. It is just like a cursor over there. Okay. Fine. Similarly, I have write and write lines. So with the write, I can write a string onto the file. With write lines, I can write a list of lines onto the file. So the way that I opened it with R, I can open it with W. Then I can do write or file.write. I can do file.write lines. It's the same way. One thing you need to be careful of is if you open a file in write mode, the file is emptied and you start writing from the start. So if you have a file with data inside it already, you can't directly write using write mode. We have a different mode for adding more data, which is called append mode. Okay. Now, whenever you finish your work with a file, it is good behavior to always close the file. If you do not close it, it will keep on using the memory inside your computer, and that will cause issues further on. So one way to avoid forgetting closing the file is to use this syntax. So with is basically a context manager. So you say with, you open the file as new file. So this is equivalent to new file is equal to open of file2.txtw, the way we did it here. It's equivalent to this. But the thing is, once you exit this with block, once you go to the next line, once you go back, the file will automatically close. So you don't need to worry about it. So I opened file2.txt in the write mode and I wrote down something else in the file. Now let's look at file2.txt. It has something else written in it. Even if you don't have a file, I will delete this file. Now I'll run this code again. It will create a new file with that data inside it. But if I have something already written here, apple, mango, banana, I save it. Now if I run this, everything will get replaced with something else. So you have to be very, very careful while writing into a file because you might lose your old data. Now, if you have A, this is append mode. So if I write into the file and then if I append into the file, so I will write this, I will write this, I will write this. So I write these 3 lines into the file. Now if I run this, the previous data will not be deleted and it will just be added on top. Some of you might be wondering what this \n means. This is basically the symbol for pressing enter. If you want to go to the next line, you press enter, right? This is the symbol for that. It's called the new line symbol. Okay. Right now we were reading just text files. Text files basically just contain text inside them. But you have a lot of other types of files. You have docs files, Excel files, image, PNG files, binary files. So all of those can be read in a similar way. You have to use something called binary, read binary. So R is for read mode and B is for binary. So this horizon.png is basically this image. Okay. But internally it is stored as a binary file, not a text file, right? So when I read it as a binary file, it will just print a series of characters which are read using binary. So basically it's a bunch of gibberish only. Because this is not how it's meant to be interpreted, right? This is meant to be interpreted as an image. But we are forcing to read it as a binary file. A lot of data nowadays is stored as binary files because it's more compact. So if the data actually consists of things inside it which are not like an image, then if you read it like this, you'll be able to read the proper data. Other file handling stuff can also be done. You can delete a file, you can rename a file, you can create new files, all kind of stuff is there. Okay, so that is file handling. Okay, so object-oriented programming. Python is, to its core, an object-oriented language. Now, what does that mean? So that just means that every single thing in Python is an object which belongs to a class. So many of you will not know what that means. So a class is basically a type of object. For example, a fruit, if I say fruit, that's just a concept, right? I'm not talking about a particular fruit. The concept of fruits is a class. If I talk about a particular fruit, that is an object which belongs to that class. Does that make sense? So, for example, int is a class. If I say x is equal to 5, x is now an object of the int class. So there are some inbuilt classes in Python which we have been using till now. For example, int is a class, string, range, tuple, date, all of these are Python classes. So the thing is, we can define our own classes with their own properties and their own attributes. So again, once again, won't go deep into this. This is just to give an introduction to modules. So a class basically contains some information inside it, and it contains some operations which can be done on it. For example, on integer, you can do the addition operation. On a list, you can do the addition multiplication operations. You can do an append operation. All these operations are all properties of the class, and the values inside it are also attributes of the class. A class is basically an abstract type, and an object is the thing that belongs to the class. So when we get to modules, a module is basically a bunch of functions created by someone else for us to use. So if you ever think, can I do this thing using programming? There's a very high chance that someone has already made a module for it. Somebody has already written those functions for you, and he has put it on the internet, and now you can use those freely. Modules are just functions, and libraries are like sets of functions which are given to you in a file, and you can just use them directly. So everything inside these modules is organized using object-oriented programming. This is a big concept which takes time to understand, and it's not completely relevant to physics and astronomy here, so I'm not going deep into it. I hope that is fine. Okay, it's around 11:30 now. Should we take a 5-10 minutes break?
I wanted to ask something related to the binary file part. Can you
Yes.
when you in this part, binary files means zeros and ones. So why do we get other things like alphabets, like when we are
Yes. Okay. So the /x00 basically represents, I think it's hexadecimal for 0000. So we can print zeros and ones over here, but uh, a string of 4 bits can be written as a single hexadecimal digit. So that is what we're writing it as. So this is the 0th hexadecimal digit. This is the 4th hexadecimal digit. Something like that.
okay. Thanks.
You might notice that this is a word PNG. The letters PNG come when we read it as binary, and this is a PNG file. So many files just store the name at the start uh, to make sure that anyone reading the file in binary is able to figure out what the file is. This B at the start means that the following string is a binary string.
I have one question. In the
Yes.
read lines syntax that you have written, it reads after what it is has already read. Why?
Yes.
So why don't it read from the start?
We can read from the start. There's a function called seek in which you can move the cursor to the start. Basically, the purpose of read lines is to start from wherever the cursor is and go to the end. That's just how the function has been written. If you want to read from the start again, you have to move your cursor to the start to something using something called seek. If I do file.seek, I don't remember exact syntax here. Let me try 0.
0.
Thank you. So if I do file.seek 0, now it will start reading from the start.
Okay, got it. Thank you.
Okay, fine. Fine, let's take a break till 11:40 and we'll meet again after that. Any questions till now? You can ask me now. I need to go to the bathroom also.
One doubt.
Yes.
For the binary files, do we not need to import pickle?
There are some modules which help us read binary files as well. But Python also has inbuilt functionality. You can use that module.
But can I just not use pickle at all? Like, why is it there?
It provides additional functionality in handling binary files. This is just the basic functionality. It reads the binary file directly as the bit goes. That module provides us with some more functionalities about binary files.
Thank you.
Okay.
बास्केट मेट्रो के लिए आगे चल ये रहा दूर होगा वैसे
Hi, is everyone back? Let's restart. Is my screen visible?
Yes, sir, it's visible.
Okay, perfect. So till now we learned how to write our own codes in Python. Now modules are essentially just pre-written codes. Someone has already done the hard work for you, and you can directly use those codes inside your own bigger codes. So the way you import a module is essentially just a folder or a file lying somewhere in your computer. The way you tell your program that I'm referring to that program is using the import word. So you say import module name. This means that everything inside the module is now accessible to your program. If you do not want to import the whole module and only some parts of it, you can say from module name import submodule 1, submodule 2. If you want to import everything, you can say from module import star. Star essentially is a wildcard character saying import everything. Sometimes the module name is quite long, so you can give it a nickname or an alias. So you can say import module as M. If you don't want the whole module, only a submodule, you can also, once again, similar to this, you can also do import module.submodule as SM.
I have one question. Do we need to
Yes.
download the module in our PC first, or would it already catch up from the net? As there is nowhere written whether it is present on the web or on our own library.
Okay, I can understand. I can explain. So there are some modules which come inbuilt in Python. So these get downloaded the moment you download Python. For example, the random module. Now there are some modules which you need to install from the internet. So there is actually a very simple way to do this, and it's provided by Python itself. I'll show it to you right now. I'll share my whole screen. Can you see my whole screen? So I'll go to the command prompt. I will say pip install, and I'll put down the module name here. For example, if I want to install numpy, I will say pip install numpy, and it will install it. For me, it's already installed. That's why it's saying this. But if there's any module on the internet, if you do this, it will be ready to be used inside your program immediately. So you don't need to worry about where the module is placed. Yes.
Yeah. So what is the difference between import module and from module import star?
They're essentially the same.
Right.
This imports the module. This imports everything from inside the module. How do I explain that? So, I mean, you can Google it also. I'll try to explain right now. So, if I do random.random now, so it will give me. Oh wait, I have to import random. Then I do random.random, and it gave me a random value. I'll go through this later. But if I do from random import star, and then I can just do random then. I think. Yes. So if I do import star, then while calling the function inside this module, I don't need to mention the name of the module. Previously, I was doing this is the module name dot function name and calling it. But if I do from module import star, then I don't need to mention the module name at all. I can directly use the function name. That is the difference.
Wouldn't it work the same if you only use import module name with the module function below?
Sorry, what?
I'm saying, wouldn't it work if you just use the import module name and just below the function? I'm saying,
Okay.
wouldn't it?
I never tried that. Okay. You're saying I should do random and then I should write import random.
Yes.
Okay. Let me try. I need to clear. Restart. The thing is, random has already been imported, right? So I need to restart my kernel, so it gets unimported after I can try this. So if I have random.random, I don't think it will work, but let's try. Yes. So at this point, it does not even know what random means, and after that, import random. So it will not work.
No. I was asking first, write import random, and below it use the random function. Wouldn't it work the same as that one? Import random, and in the next line random.
This
Yeah.
rate? No, it will not work.
So to invoke the random function in the inside of the random module, we need to write it as random.random.
Yes.
Oh.
Random has many functions inside it. One of them is the random function. I know it's kind of confusing because the name is the same, but that is how it is. I forgot what the original state of this was. So sometimes you don't know what the function here does. So you can do something called help. So if you say help of module name, it will give you a lot of information about the module. So this is around, I don't know, hundreds of lines of information about this module, about the functions inside it. You can go through this if you're ever confused about what a module does. You can even do random.random. Now it will give you information about the random function. It says it's a method of random.random instance. It gives the x in the interval 0 to 1. So to access functions inside a module, you use a dot notation. So this was a simple example of a module. So whenever we want to randomize something, you can call the random module. There's a lot more functions inside this random module. There's randint, which gives a random integer. There's rand range, which gives a random list, I think. I'm not fully sure. But there is a lot of randomizing functions inside this. So one of the most popular modules in Python is called numpy. Basically, it's numeric Python. So till now we would have seen, I didn't mention this explicitly, but in a list you can store values of different data types in the same list. You can even store a list inside a list, a tuple inside a list. So this is a valid list in Python. Now this has a lot of advantages about, you don't have to worry about data types. Python is one of the languages in which you don't care about what data type it is. There's something called dynamic typing. Now L was just now a list, right? I can just assign an integer value to L. Now if I print L, it will be an integer. So Python internally handles all of this. Many other languages, if a variable is of a given type, it stays of that type forever. So you can't do things like this. That was kind of a tangent, not related to NumPy. So NumPy gives us a lot of interesting functions about n-dimensional arrays in Python. What are those interesting things? Let's go through those. So first of all, to import NumPy, we write import NumPy. As NP is something a lot of people use because they don't want to type NumPy every time, they just type NP. So the basics. So in NumPy, an array can have data of only one type. They are homogeneous. So either everything inside is an integer, everything inside is a float, everything inside is a. I think those two are the only ones allowed. So the way you convert a list into a NumPy array is you write np.array of the list. NumPy. Now if I print a1, I'll get 1, 2, 3. So a1 is a NumPy array containing 1, 2, 3. And in a normal array, I can't do stuff like this. So it gives me easy ways to access the size of the array. Otherwise, I have to do len of a1. I can do dot size. I can make a new array and I can get what type of data is inside it. So I can get dot data type. Here it's float 64. So you can see that everything inside here has been put as int except for one point. Now there's one point. The point means we want to store it as a float. And because everything in the NumPy array has to be of the same type, everything gets converted to float. Now if I print a2, it will print everything as floats inside. So a NumPy array has many attributes that I can access directly. I can access the number of dimensions. I can access the shape. So the shape of this is a 3 by 3. Shape of this is a 1 by 3. I can access the size, which is total number of elements. I can access data types. These are very, very basic functionalities that NumPy gives us for arrays. Right now, it seems kind of trivial. These are small arrays. But when you start dealing with huge arrays that you're getting from huge data files, this is really, really helpful. Okay. This is something called an f string. This is not related to NumPy at all. But basically, if you want to print out the value of a variable, if I do x is equal to 5, if I do print, I can do print x. and it will print 5. I can print x is equal to x, and this is also print 5 here. I can also do print x is equal to this also print 5 equal to 5. These are basically different ways to put variables inside your outputs. So if you want to print dimensions of A1, dimensions of A2, so you can print them like this. Again, A1 dot shape, A1 just has 3 elements in a row, so its shape is 3. If I print A2 dot shape, I get 3, 3. Now, the biggest advantage of numpy is vectorization. Basically, instead of treating the list as just a collection of values, we can treat it like a mathematical vector. So, for example, if I have an array and I want to square every value inside it, the easiest way someone would think of it is for E in array. Wait, that also won't work. For E in range of length of array of E is equal to array of E raised to 2. What did I do? Why didn't run this? So now this will square every element in the array. I ran it twice by mistake. Wait. So this is the simplest way someone can think of it. Now Python gives us a way to do it inside the array itself. So I can do I square for I in array. And now this will also give me the same thing. It will give me the square of this. The thing is, if you have a numpy array, you can do this very easily by just using this notation. Raised to 2. If I try to do array raised to 2, this will give me an error. Because the power operator does not have any meaning for an array. But numpy gave a meaning for it to numpy array, which means just square every single element inside. Note this is not like matrix multiplication. This is element-wise squaring. So similarly, if you try to add 2 arrays, they will get concatenated, right? But if you add 2 numpy arrays, you will have element-wise addition, which is like what happens in vectors and maths. Similarly, you can do element-wise multiplication, element-wise division. You can basically take the program for one element and apply it to the whole array, and it will get applied to every single element in the array. That is the power of numpy.
Just a small doubt. So suppose we multiply two numpy arrays. So does that is it equivalent to vector multiplication? Like
no, we will come to that. So we can do element-wise multiplication as well as matrix multiplication. We will come to it later.
Okay.
You can do a dot product. You can do element-wise multiplication. You can do matrix multiplication. Everything is available in numpy. Okay. So another way to get help regarding a method is to put down the element thing and put a question mark after it. This does not work in Python, by the way. This only works if you're using Python in a Jupyter notebook. So this gives us all the information about an array, the array function. Okay. Now, if I have a 2-dimensional array, I can convert it into a numpy array. And I can also specify the data type. Now I said it's complex, so it stores them as complex numbers. J over here is I. The square root of J is square root of -1 over here. So it's 1.0 plus 0.0 into J 2.0 plus 0.0 into j. So it converted into complex. Now it's showing them as a numpy array. I can also specify the float data type and it will store them as floats. Numpy lets us initialize simple arrays like zeros. If I do npy of zeros 4 8, ones of 4 8, it will just make a 4 by 8 array of all ones. Zeros does the same thing with zeros. Empty basically creates an array with garbage values inside it. If you haven't worked with programming languages before, you might not know what garbage values mean. Right now, see, basically in memory, sometimes some value is stored which was used long ago. Now we don't care about it, and now if that memory gets assigned to our array, that already has some bits inside it, right? Some of them are ones, some of them are zeros. So that is known as garbage values. So when you make an empty array, basically it does not initialize the values. It just has the garbage values over there. Over here we got lucky. The garbage values are 0, but you might not always get lucky. The last time I ran it, I was getting around 10 raised to 15 in some of these places. So you can think of them as random numbers, but they're not exactly random. They are values that are stored inside your computer, which haven't been changed. They were used some long time ago, and we're just directly getting those. So an array can be initialized as sequence using these methods. So I talked about range before. There's a numpy.a range. It's almost the same. The A stands for array. So it is numpy.array range. And again, once again, we have start and step size. So if you provide the start and then step size, it will create a numpy array which creates elements from 1 to 10 with steps of 0.2, and 10 is excluded. The upper limit is always excluded in Python. Similarly, line space, you can give a start and end and number of elements, and it automatically chooses the step size and gives you a numpy array. These are very useful if you want to create something like a number line. If you're plotting something and you want to have an x-axis and you want to decide which values of x I want to sample my function at. So these functions are very useful in those cases. Okay. Operations.
Range is the end limit included or excluded?
Excluded. In linspace, it is included, I think, as I can see it here. Here it is excluded.
Yes, linspace.
Okay. Operations. Now, as I told you, yes.
Like, what is the difference between the linspace and arrange?
The arguments are different. Here you can specify a step size, and here you can specify number of elements. One can be simulated using the other, but it's just for convenience. Okay. Now you can do simple operations like a into 3 on numpy arrays. Now if I do, so a is 0 to 23 140. If I do a into 3, it multiplies each element by 3. It does not create 3 copies and concatenate. This is what we might mean when we say multiply the vector with 3. We don't mean make a 3 by 1 vector into a 9 by 1 vector, right? Same way you can do b into 2. You can do a plus b and does element wise addition. A less than b and it does element wise comparison. So it compares consecutive elements, and if the comparison is true, it will give true. If it's false, it will give false. So all kinds of things that can be done on int, floats, complex numbers, all of that can be done on numpy arrays as well, if you want to do it element wise. Now multiplication, if we want to do element wise multiplication, we can use the regular star operator. Here it is. So 2 into 0, 4 into 1, 6 into 3, 8 into 7. If I want to do matrix multiplication, I can use the at operator. So 2 into 4 plus 0 into 3 is 12. You can go through it on your own. The dot product is basically the same as matrix product again. So you can do a dot of b, and it will give you this. Now numpy also provides us with a lot of specialized functions. For example, sine, exponential, minimum, sum, transpose. So this applies the sine function on every single element. This applies the exponent e raised to x function on every single element. This finds the minimum value in the array. This finds the sum of all the values in the array. This finds the transpose of the array. So all these functions, if you were to write them from scratch, it would take around 6-7 lines of code at least. But over here, you can do this all in one line because a community has written the numpy module, and now you can just do it in one line. Slicing. The same way that we slice lists, we can slice numpy array as well. So I don't think I mentioned the third argument in lists. I only mentioned the first two, but it works the same way over here as well. So I'm creating a random. Is it random? No. It's sine of values from 1 to pi with 8 values in between. I just picked something random. It's fine. So if I do 1 of 1, 8, 2. So essentially this means I start from 1, I go till 8, not included, and I skip every second element. So I didn't take 0, I took 1. I didn't take 2, I took 3. I took 5, and I took 7. This is start, stop, and step. Now the thing is, if you don't mention some of the things, some of the elements, Python interprets it on its own. If you don't give the starting value, it will start from 0 automatically. If you don't give an ending value, it will end at the end automatically with the step value equal to this. And you can even give negative step values. If you give a negative step values, it goes backwards. So here I didn't give a start and a stop, and I said go backwards. So intuitively, this would mean start from the end and go backwards, right? So it just reverses the full array. All of this applies on normal Python list as well, by the way. Okay, now I will make a 5 by 5 random array. This is not the same random module as before. This is a random submodule inside the numpy module. And this gives us a random function, which if you give it a size, I gave it a size 5 by 5, it creates a 5 by 5 array with random values between 1 and 10. So this is such a random value. Now, if I have 1 colon 3, comma 1 colon 3. So this 1 colon 3 refers to the first dimension of this array, which is the rows. And the second one after the comma refers to the second dimension, which is the columns. So can anyone tell me what the output of this will be?
Can you explain this part again?
This part?
Yes.
So this is the same kind of slicing we had before. This 1 colon 3 refers to the outermost list, the big list which contains smaller list inside, the first dimension. And the inner one corresponds to the inner list, like slicing the inner list themselves.
Two three seven three. Sorry, 7381.
3411.
That's right. I think it will be 3411 because the counting starts from 0, right? So 1 1 will be here. Yeah, yes, it is 3411. Any questions about why? I can explain it again. So if you have a large database and you want only a part of it, you can use slicing. Yes.
It is from 1 to 3 we have done. Then I
Yes.
guess it should be 3 4 6 also now.
No, but the upper limit is always excluded.
Okay.
It starts with 1 and it stops when it's equal to 3. So it will not take the 3 value. Okay, similarly, I can make a 3-dimensional matrix. So this is 5 by 5 and there's 3 of them. Now we don't have 3 dimensions on the screen to show this. So this is the first matrix, second matrix, third matrix. So if we look at this kind of confused me as well in the start. Essentially, for the first dimension, I am not doing anything. Second dimension, I'm not doing anything. In the last dimension, I'm not doing anything. But in the middle dimension, I am taking only the second object. So let's go through this slowly. So the 0th dimension, this is the biggest list containing 3 elements. 1, 2, 3. So I'm not doing anything. That means I'm considering all 3. Now, in the next dimension, which is this thing which contains these rows. So I am taking the second row in each. So 0, 1, 2. So I'm taking this row, I'm taking this row, I'm taking this row. And now in the last dimension, which is what is inside these rows, I'm not doing anything. That means I'll get the complete rows. So I got this complete row, followed by this complete row, followed by this complete row as my output. Okay. Okay. There are some more functions about changing the shape of an array. So there's something called ravel. So if I make a random array here of 3 by 3 by 3 size, if I ravel it, it basically takes all the elements consecutively and it makes it into one long array. So 3, 4, 4, 2, 4, 3, 1, 3, 4, 2, 2, 4, 3, 4, 2, 4, 3, 3. That's the exact same order it is in here. So just all the values in one array. If I do reshape of 3, minus 1, it turns it into an array with 3 rows, and minus 1 means just do what is necessary. So I said minus 1, so I just filled it so that it was exactly a rectangle. If I do reshape of 9, 3, it turned it into 9 rows and 3 columns. It's the exact same values, just you change the shape of the array. This is not too important. Also, if you ever need it, you can just Google syntax for this. This is not too difficult. Making copies. This is a common problem in Python. There's a similar problem with lists and dictionaries also, I believe. So if I create an array A, this is my array A. If I say B is equal to A, B will be equal to A. Yes, B now stores the same value as A. Now, if I multiply A with 2, every element in A should get doubled, but B shouldn't change, right? But if you look at B, every element in B has also been doubled. So the equal to operator, it does not create a copy and give it to this guy. It essentially creates a link between them. Basically the variable A, it points to somewhere in the memory where all of this is stored. And when you do B equal to A, B also points to the same place in memory now. So if you change the values at that place in memory, B will also recognize that change. Now, many a times we do not want this to happen. We want to make a completely new copy. So that's where these functions come in. So there's a dot copy function and a dot view function. So if you do a dot view function, if you do B is equal to A dot view, it makes a copy of A. If you reshape A, nothing, B will not change. But if you change the values inside A, then the values inside B will also change. So basically, the shape of the array gets fixed, gets copied properly, but the values inside are still corrected by rings. So if you want to make a completely deep copy, in which everything is copied, there's no links between them, you have to use A dot copy. Now, if you make any changes to A, it won't reflect in B. Okay. So this was one of the big modules, NumPy. Now, the thing is that many other modules use the NumPy module to come up with even more exciting functionality. Any questions till now?
Can you explain the shallow copy again, the second point?
So a shallow copy means the shape of the array is properly copied, but the values inside the array are still linked. So if you change the shape of the original array, the view will not change. But if you change the values in the original array, the view will change.
Okay. Can you give me an example of that again?
Yes. So I have A as a random value. I'll print A. This is my random A now. Okay. Now I'll make B is equal to A dot view. Now, right now this has the same values as A had, right?
Yeah.
Now if I do A dot reshape, now the shape of A changed. But the values inside
yes.
A are the same. But if I run B, the values inside B are still the same. But if I change the values inside A, I multiplied everything inside A by 3. Now if I look at B, the values inside B have also gotten multiplied by 3. But the shape is still retained.
Yeah, I got it. I got it. Thank you.
Oh, okay, great. Okay, any other questions? Okay, great then. So this was a module for numerical calculations. If you want to do matrix multiplication, instead of writing a big code, you can just use the function and you'll get multiplied matrices very easily. Okay, now let's say you have some data and you want to plot it on a graph. The matplotlib module provides us with functionality for that. It's a visualization library which can provide static, animated, and interactive visualizations. So matplotlib is a huge thing. We will look at only one submodule of it called pyplot. So I'll import matplotlib.pyplot as PLT. I already imported numpy before, so I don't need to do it again. But it's fine, no problem. I am right now fixing the figure size to 10 by 7. You don't have to do this optional step. So if I do plt.plot of a vector, if I give any series of numbers here, I can give the plot a title. If I show the plot, I will get x and y axis. Now this is the index. So at the 0th index, I have 1. At the first index, I have 4. At the second index, I have 3. At the third index, I have 7. At the fourth index, I have 9. Now this created a plot of these values. Now this was if I give plot a single input. If I give it 2 arrays as inputs, I created a new array A, which is just line space of 1 to 100. Then np.sign of A, as we had seen before, is just another array in which every element is the sign of the corresponding element, right? I'll comment this out for now. So if I run this, I'll get a sign function. This r dash specifies the color and the type of plotting you want. So the r means it will be red, and the dash means that it will be this kind of dot dash plotting. So dot dash, right? That's what r dash means. Now, if I want to plot a cos with b, and the colon means it will just be a lot of dots. Now, this is a cosine function. Now, if I have a log function, I can get a log function here. If I want a tan function, I can get a tan function here. The black line is a tan function. It has been scaled down by 0.01. I'll also do this. The issue with that is because tan takes so many values till infinity, everything else gets squashed down in this graph. So let me make it separate. This is tan. Now you can see that you don't get every single value in tan, right? There's lots of missing gaps. This is because of this line space. I took values from 1 to 10 and I took only 100 values in between. That means my least count is just 0.1. So it finds the value of the function at every 0.1th place and just draws a line connecting them all. Now, if I increase the number of points, if I make it 1 zack, it will take 100 times the time, but it will also be more accurate. Tan is kind of a messed up function because if I get closer here, I get bigger values, and now that squashes everything else. So tan might not be a very good example here. Someone was trying to say something. I heard someone unmute. It's an exponential function. Right. So you just have an x array, the values you want on the x-axis. You have a y array, the values you want on the y-axis, and you can just plot them. Plot 0, 1, 2, 3, 9, 8, 7, 6. So I just run this. It makes a line for that. Fine. Now this in this plot. Yes. Is someone asking something?
Can you explain this? The one with two lists.
I think you'll better understand it if I use the scatter. Essentially, it plots the points 0, 9, 1, 8, 2, 7, 3, 6. Okay.
Okay, fine.
And if you use the plot function, it thinks that it's a continuous function and tries to join them using a line. Okay.
Okay. But 2 points, suppose there are 3 points, so there are infinitely many ways to join them. Like,
yes. So it finds the best fit, kind of.
Okay.
Sometimes it gives a very bad graph for what the points are, but in most of the cases it makes a pretty good one. I think it joins every single 2 consecutive points by a straight line. Let me try it out. I didn't try it before. Yeah, it just joins everything by a straight line. There's no fitting involved. 2 consecutive points I joined by a straight line.
Yes, so the log graph that we were drawing, then.
The thing is that there are 1000 points here. So it is made of a lot of straight lines, small straight lines.
Okay, fine.
So plot is good, but it's not always useful. Sometimes we want to use a scatter plot. For example, here if you try to make a plot, let's see what is up. Yeah, this is a very useless figure because it just joins consecutive points. So if you want to visualize data using a scatter plot, there is a scatter function. There are a bunch more functions which you can use. These two are the most commonly used ones. So this is matplotlib for you. There are a lot of customizations you can do. You can add multiple subplots inside a plot. Everything is available online. You can go through matplotlib documentation. Okay. Okay. Now we come to pandas. This is the last quote unquote boring library. After this, I have some interesting libraries coming up. So pandas provides data analysis tools in Python. It is built on top of numpy. And so basically you can have something like a database. It's called a data frame in pandas. Okay, so let's create one. I'll import pandas as PD. PD is a usual short form for pandas. So I made a, if you have a one-dimensional array, it is called a panda series. If it's multiple dimensional, at least 2 dimension, it is called a data frame. Usually you don't go over 2 dimensions in pandas. So if I make a series of this, it basically makes a data frame. These are the indices 0, 1, 2, 3, 4. These are the values 1, 2, nan, 3, 12. 12 is 4, 5. Nan indicates not a number. So if I have anything which is not a number here, it will say nan. So and the data type here became float 64 because of this person. If I make a 4 by 6 random array and I convert it to a data frame, it will become this. These are the default column names and default index names 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. But we can change the.
Can you reiterate the function of pandas? I sort of missed in writing. What does the pandas actually do?
Pandas basically allows us to work with databases. You can have a database as a pandas data frame, and it gives us a lot of functions for searching, for sorting, for slicing data frames, which numpy does not provide. We will go through those, some of the interesting functionalities. Fine. So if I have a pandas series, I can have this a pandas data frame. These are the default column names. I can also set column names and index names. So right now it's just 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, and these are the values inside. I can change the indices. I can name them ini, mini, miny, mo, and I can make a new data frame. Random values inside it. Indices are these indices, and columns are A, B, C, D, E, F. So the column names are now A, B, C, D, E, F, and these are the index names. Now let's say I have data, a data frame with thousands of rows. Then if I want to look at only the top few rows, I can just do head. And if I put 2, I get the top. I get the top 2 rows. If I do tail, I get the bottom 3 rows. If I do a dot columns, I just get all the column names. A dot index, I get all the index names. If I do a dot describe, this is an interesting function. Basically, it gives the total number of variable, total number of things in each column, the mean of each column, standard deviation, minimum, 25%, 50%, 25%, maximum of each column. It provides us with some statistics of each column. We can slice it the same way. For example, this is bad naming here. I shouldn't have named the database A, but I'll change that. So I have a database called ABC. If I do ABC of A, now it gives me just the A column, just this column from ABC. If I do ABC dot lock, basically lock means locate. So it locates the row in which the row name is MO. So it gives me that row. Now this locate command is actually very, very versatile. I won't go very deep into it, but you can essentially put a lot of conditions, and every single row which satisfies that condition will show up. So the value at C should be greater than 0.6. So only these 2 rows should up. I locate is basically index locate, locates the row using the index. So the 0th row will show up. In here we can put down a condition, and only the rows in which A is greater than 0.5 will show. Nans also show because nans return true for every operation, I think. Less than 0.5 also nans show up again. But only the A values less than 0.5 show. So you can access rows of the database data frame using conditions like this. All of this can be done without using any package as well. But once again, it will take around 5 or 6 lines for you to write that code. And here you can do it in just 1 line. That is the whole power of pandas. Pandas also provides some file handling inside it. You can easily read a CSV file. You can write to a CSV file very easily. Any questions to here?
I want to ask what was that 25%, 50%, and 75% in that describe?
Yes. Okay. Let's find out what it means. So I do help of pd dot data frame dot describe. Okay. So first of all, it gives us the list of like numbers percent. No, not this is parameters. Returns. Thing is, I'm not sure what it returns. I'm looking through it right now. That's the beauty of Python, right? The documentation is so good, you can find out whatever you want easily. It gives us the number at 25 percentile.
Okay.
Nice question. Any other questions? All of this was just basic Python functionality till now. Now, from now on, we'll be using it in actual physics and astronomy.
All the values in the data frame that we see are random, or are they based on some format? So
you can assign those values. I initialized those using the random function. That's why they appear to be random. But you can set those values. Right now, these are random values, yes. Okay, anything else? Okay, one thing I forgot to mention, by the way, this session will help you understand the data-driven astronomy session, which will be taken later. That will also be, that's an astronomy, data-driven astronomy session. It's based in Python. So a lot of the things that you learn here, and the instructor on that day will teach you some more Python things. All of these will be used in that session. Not all, quite a few. So if you're familiar with Python by then, I think that session is, it's not this week. It's sometime next week, I think. So till then, whatever doubts you have, you can always contact us on the Teams channel or on the WhatsApp. Fine. Okay. Let's go to scipy. So scipy is in Python is again one more open source library, and the purpose of this is for scientific computing. It allows us to manipulate data, visualize data, and it's been built. It's once again built on top of NumPy. Nowadays, everything is built on top of NumPy. So scipy has thousands of functions, and I don't have time to cover even a small fraction of them. These are some of the main sub packages of scipy. You can see you can do input output. You can get special functions like the Gaussian function, Bessel functions. Everything is available here. You can do linear algebra operations. You can do interpolations. You can do optimization and fitting. You can do statistic stuff. You can do integrations. You can do Fourier transforms in case you know what that means. You can do signal processing, image manipulation. All kinds of things are available inside scipy. So let's look at the few most important ones, which I tend to use personally. Okay. Import scipy.optimize. I didn't import the whole scipy module. I imported only this submodule from scipy. So we look at the function scipy.curveFit. So this function basically allows you to fit a curve to the data. So you give it a function, you give it some data, and it tries to fit that function to that data. For example, if you are given some data and you know it is a quadratic function, but you don't know in y equal to x plus bx plus c, you don't know the values of a, b, and c for that function, right? So using this curve fit, you can find the parameters a, b, and c such that your function will fit the data very closely. Okay, so this is basically some synthetic data. Synthetic means it's not from a real astronomical source. It was created for this demonstration. So it contains a wavelength and then a brightness. It is supposed to represent the 21 centimeter line from a galaxy. If you know what the 21 centimeter line is, then great. If you don't, I would recommend you look into it. It's very interesting. Basically, it's one of the emission lines. One of the emission lines. Everyone will know what emission line is from chemistry. But it's one of the emission lines from neutral hydrogen. So first of all, I read that file using pandas.readcsv. Then I store the brightness values inside y. I store the wavelength values inside x. And then I plot a scatter plot. So basically, these are all the data points available inside the file. Okay. Now I define a my Gaussian function. So I think this looks like a Gaussian function. For those of you that don't know what a Gaussian function is, this is exactly a Gaussian function. So it's a constant into e raised to x minus mean square by 2 sigma square plus b. So it looks like a Gaussian function. So I don't know what the values of U, S, A, and B are. So what I will do is I will say optimized value is equal to scipy dot optimized dot curve fit. The function I want to fit, the X values I want to fit on, the data, the Y values that the final output my function should give are, and this is an initial guess. Many times you don't need to give an initial guess, but it's always better to give an initial guess. I can look at this and say, okay, the mean is approximately 21. The standard deviation is approximately 0.01. I can say stuff like that. And this will basically help my curve fit function be faster and more accurate. So I run this. Okay, I run this first. This is my initial guess. This is my function. And this is my data. So it tries to find the parameters such that my function fits this data. And does anyone have any questions about what that means?
Yeah, can you explain this part once more? The optimization.
Okay. I have some data. So I have a series of X values and corresponding Y values. I think that this data follows a Gaussian. A Gaussian is basically just a function which takes X and gives out a Y, right? It is, to be exact, it is this function of X.
Okay.
Now, just like a quadratic has some parameters A, B, and C in AX plus BX plus C, a Gaussian also has 4 parameters A, mu, sigma, and B. Now, I want to know for what values of U, A, sigma, and B does a Gaussian function fit my data very well. Right? So that is what the curve fit does. So there is some very specific syntax for it. So my function's first input should correspond to this X. And the rest of the inputs, I haven't covered this before. I'll explain it in a moment. So basically, I can put a lot of inputs here. If I have a star P, that means I can put multiple inputs and I can catch them as one input here. Basically, I can unpack. I haven't explained unpacking either. If I do that. T is equal to 2 comma 3. If I do this, now T is a tuple, right? If I do A comma B is equal to T, if I print A, now A has the value 2. If I print B, B has the value 3. So this is called unpacking of a tuple. Right?
Yeah.
This kind of syntax unpacks a tuple. Now, if I just write down another way to do this, if I just write down star T. So it gives me 2 and 3. If I print T, it'll give me 2 comma 3. But if I print star T, which is unpack T, make it a bunch of values instead of a single tuple. If we do this. So essentially, this takes multiple things as input and it unpacks it inside.
Yes, fine.
So this my Gaussian should have X. Okay, understood. Great. My Gaussian should have X and the series of these parameters which I want to find. And then this is the data X and Y and my initial guess. So this will give me an opt, and inside it, it stores the values of mean, standard deviation, amplitude, shift. Now it gave me these values. How can I believe it? How do I think this is correct? So I can plot it. So I plotted my original data using a scatter plot, and I plotted the function I got. X, my Gaussian, X, and these are the parameters that I got from the curve fit. I plot these at the same place, and you can see it almost exactly matches. The red line is the curve I got, the curve fit, and the blue dots are the data. So just using a few lines of code, I can do this. If you try to do this on your own, first of all, learning it is a huge pain. You have to do something called chi-square fitting. It's a long process. So everything has been automated for you. You can do it in 2 lines. So this is very, very useful in astronomy, especially in spectrum analysis. If you have maybe a black body function, so you will know from 11th grade that 11th or 12th, I don't remember, that The black body function depends only on the temperature of the body, right? So if you get data about emissions at different frequencies for a star, you can fit a black body function to it, get the value of this parameter, and that parameter will be the temperature. You immediately know the temperature of the body.
Yeah, we can also find out then area as well, because we can find the area of the star or the body as well from that.
Yes. There are other ways to find out area also, though. There are a bunch of other ways to find area also. I won't go to those today. Okay. One more function inside scipy is called quad. Essentially, it is to integrate any function in one variable. So I picked an interesting function for this. So the Navarro-Frank-White profile is basically a model for how dark matter is distributed in a galaxy. This model predicts real-world observations quite well, better than most other functions that we have. So this is someone saying something?
Sorry, can you repeat the last few things you said? Just the dark matter stuff.
So this is a profile for the radial density of dark matter in a galaxy. This is not something experimental, it is a mathematical model. And this is a model that works decently well. It matches with observation decently well. So this has a Wikipedia page about it. If you want to read more, you can read more about it. Now this is the exact radial distribution function. Now I want to integrate this function and find the total mass enclosed, total mass of dark matter enclosed at a given radius. So for that, I have to integrate this dr, right? I will do 4 pi r square, the function dr, integrated from 0 to r. Now I integrated it by hand and I got this value, but that's not where the fun is, right? So first of all, I plot the function. Plot the function. This is the radial distribution function. Then I integrate it using this value, using this function, scipy.integrate.quad. So I give it the function, lower limit, upper limit, and because this function has multiple arguments, not just the variable of integration, it has some more things. So I provide those some more things also to this function. So it integrated and it gave me the value of 620. Now I had integrated it by hand, and this is the analytical solution. And if I check the value, it's essentially the same. It is same to the first 12 decimal places. Right? So you can use this function to integrate from lower limit to upper limit for any one variable function. There are similar functions for multiple variables as well in the integrate module. Okay, one more thing. If you don't know what eigenvalues and eigenvectors are, this might not make too much sense. If you know, then you know how exciting this is. So if you are given any square matrix, this function essentially finds all the eigenvalues and eigenvectors for that matrix. This is a central problem in many physics problems. For example, the Schrodinger equation itself is just an eigenvalue equation, where H is the matrix, I is the vector, and E is the eigenvalue. So I import scipy.analytic. I made up a random matrix, and then I just solved the eigenvalue equation. These are the 3 eigenvalues, and these are the 3 eigenvectors. So I can just check it. I can look at mv minus lambda v. So m matrix multiplied with v. This is the 0th vector minus 0th eigenvalue into 0th eigenvector. And you can see it's 10 raised to minus 16, 10 raised to minus 16, 10 raised to minus 15. So it is very, very accurate in that aspect. Usually these are all irrational numbers and computers don't handle those very well. That's why we're getting these tiny, tiny errors. So scipy is extremely useful in this search. So anything you want to do in mathematics, scipy has it already. You probably don't need to implement anything. You just have to look for the correct scipy function. Okay. Next, astropy. So the first line of almost every astronomy-related program is from astropy.io import fits. So a fits is basically a standard way that astronomical data is stored in files. So I have a file here called hotset.fits. So each fits file consists of an array of header data units. So I'm calling it SDU list here. So if I do fits.open of file 1, I get a list of SDUs. So to find out how many SDUs we have info about them, we can run sdu.info. So I can see I have two header data units, the primary one and the table. So it turns out the interesting one here is the primary SDU. So each SDU contains, from the name you can see, a header and a data section. The data section contains the data. And this data is usually a multi-dimensional array. Here it's a two-dimensional array. The header contains information about the data. It basically explains to us how to interpret the data, what the data actually means. Like, it has a bunch of numbers, but what do the numbers mean? What does it represent? So I will take the 0th header data unit and I'll print out the header. So there's a lot of information. This is the number of axes, which is 2. This number of dimensions. 891 things in the first dimension, 893 things in the second dimension. This is the date the file was created. You can see that it's a photographic plate. These are the latitude and longitude of the place where the image was taken. There's a lot of information. You can go through all of it. So in this file, the first SDU, the SDU0 data is SK2D array, and it encodes the image of the Horsehead Nebula. Now PyPlot has the imshow function, which we haven't covered till now. Basically, it takes a 2D array and it shows it as an image. So it was this fits file. If I open it right now, it's a bunch of gibberish. I cannot understand it. Fits file cannot be opened using a normal image editor. There are some specialized image emitters like SAO where you can open these, but mostly you will have to use Python to open a fits file. So look at this image also.
Can you explain what is fits an extension after the file, or is it a function that we apply? I'm getting quite confused in the actual usage of fits.
Fits is a file extension. It's a type of file. Now, astropy.io, which is astropy.input-output, has a function and it has a module in it called fits. It happens to have the same name, and the job of this function is to open fits files. Any other question? Essentially, what imshow does is, if you have a 2x2 array of values, it gives a color gradient, and it gives color to that point according to the value at that point. I can actually change the color as well. So if I change the color map is equal to one of my favorites is plasma. So it's just a different color gradient. It just takes the value at that point and assigns the color according to that. This is not the real color of the image. This is the Horsehead Nebula though. Okay.
It's like adding a filter to the photo.
Correct. Actually, it's just a black and white photo, and we're adding a filter to it, so it looks nice. Okay, my part is done. Any questions? Anything you want me to experiment with? We have 15 minutes more. I am ready to sit around 15 minutes more. Any questions? Anything? I am done explaining everything I want to.
Sir, all these functions you showed us, so we have to look it up ourselves also, right? To get a idea.
Correct. You will only get comfortable with these if you use them on your own. If you look up how they work, not internally, but as in what more parameters can they take, what values do they give back. You have to play around with it to get comfortable with it. I was not comfortable with it the first day I learned it. It takes some time. All of these modules, I don't know what half the functions these modules do. I have the few functions that I use, and if I ever need something new, I just Google and I say, is there a function for this? And usually there is a function for that, and I use that.
Can you simplify how a project of astronomy is done, how the data is recorded, how is it operated, filtered, and how is it shown?
Are you talking about like astrophotography?
I am unaware of the specific word for that.
I didn't understand your question properly.
I mean, how is it that the data is collected? How is it that data is processed? And how is it that the data is represented as you are doing it? Any simple roadmap for that?
Okay. So the collection of data is usually done by one of the huge telescopes or by some organization, many times by governments, universities. So we are usually not involved in data collection because if we try to get data, it will be very, very noisy data compared to a lot of open source data that is available. So we would rather use the data available online. There are some websites on which you can get huge databases of data for whatever you want, right? So, and that data has already been cleaned, processed, so it is in usable format so that anyone can use that data and find out results. For example, this Horsehead Nebula image, I did not collect this image. I got this from somewhere online. They had already processed it enough for me to show it. Now, if I want to do some kind of analysis on this, if I want to count the number of stars on this, if I want to look at distribution of elements in this, I can do that using Python on my own. But the usable data is provided to us by these organizations. Sometimes NASA is there. There's a lot of radio data is present on, I forgot the website name. There's Gaia data, there's VLASS data, there's a lot of data available online. Okay, so once you have the data, the thing is you need to get data according to the problem you want to explore. So you decide a problem you want to explore and you look for data corresponding to that problem. And once you have the data, you run your program on it and you look at the results, you look at the errors, and then you see whether those results are significant or not. And then it's just normal stuff. Any other questions? If you didn't understand anything that I explained, I can go back to it. Even if it's in the previous notebook, I can go back to it. The recording will be provided. These notebooks will also be provided. Don't worry about that.
Can you share some resources where we can learn a bit more about NumPy?
You can just Google the word NumPy, and NumPy has a excellent documentation on the NumPy website. You can learn everything about it there.
Okay.
I think there are some YouTube tutorials also on NumPy. Everything is widely available. All of these are open source modules, by the way. If you are good enough at this, you can also contribute to the modules.
What? Excuse me.
Yes.
What is the x-axis and y-axis represent in this picture?
These are the sky coordinates.
Oh.
Not exactly. These are basically the index of that value, but they represent the sky coordinates. I didn't scale it properly, but it's right ascension and declination, the sky coordinates.
Got it.
Excuse me.
Yes. Yes.
So using this image, how will you be able to elucidate the elements that are there in this whole nebula?
Okay. I can't exactly do it with this image. If I have this is a monochromatic image, right? If I have data about every point in different frequencies, basically if I have this image in multiple different frequencies, then using the emission and absorption lines, I can figure out what elements are present.
Okay.
it's a crowd, right? So it will mostly have only absorption lines. So I can see which element lines are getting absorbed, and then those elements are most probably in the nebula.
How is it that we know that the data we are getting will provide the right correct values, as there is also so much dust as well other particles that may refract or reflect the original uh, light emissions?
Correct. No data is perfect. All data will be noisy. Yes, I agree with you. It is the job of the astronomers, the people who are operating the telescopes, to make the telescope in such a way, to make observations in such a way that the error is minimized. But when dealing with data, we need to be aware of this. Yes, you bring up a good point about the errors in the data.
That is why the eclipses and other things are more preferred. I remember reading an article how the solar eclipse helps us understand the the solar storm or what it was, its function and stuff.
Yes. The area near the sun is not really visible when the sun is shining, because the sunlight oversaturates all the cameras, right? So when there's a solar eclipse, you can see those areas nicely because the main light of the sun is getting blocked. Yes, so it's the astronomer's job to look at the right time and take the images at the right time, so that the data analysts, people like us, who can go through that data and get interesting results.
Excuse me.
Yes.
There is a Doppler effect in the electromagnetic radiations, right?
Sorry.
The Doppler effect.
Hmm.
Are those taken into accordance before the data is submitted to the data analyst?
No.
Then how will we know whether it is the right electromagnetic radiation which we are searching for?
Right. If you want the data to be submitted, the submitted data itself to be corrected for Doppler effect, how are those people supposed to know how much to correct it? It comes out as the same question again, right? So
yes,
if they're able to, yes, there are some ways to figure it out. So is that what you were asking? I cut you off. Sorry.
Yes.
So there are ways to figure it out. Now we know what the emission and absorption lines of many elements look at when the element is at rest with respect to us. That all those experiments have been done in chemistry labs to very high accuracy, right? So when we get data and we look at a line, for example, if there's a line at 500 gigahertz, if I see no line at 500, but I see a line at 502,
okay,
I can assume that this was actually the same line which got shifted, and the amount of shift will give me a hint about how much redshift is there.
Oh, so will it not be that accurate then? Like
will what be not that accurate?
The how accurate will that assumption be? Like,
no, this assumption is usually very accurate. Unless if there are hundreds of lines bunched in a very small region where we can't tell which line moved. If there's a line in a relatively empty region, we know it is obviously that line which moved there, right?
Yes.
So using this information, we can find out the velocity of the source.
Also, from that we can find the other ones as well.
Yes.
And usually in these cases, we get a mixture of atomic spectra, right? Like there will be a mixture of elements which leads to a mixture of atomic spectra. So how is it that we figure out each of them? How do we separate the elements and find out the composition?
So as I said, the redshift usually isn't that big. It's if you consider the fractional change in wavelength, that is usually very, very small. So you have to just look in the neighborhood of that data. For example, this 21 centimeter line I showed you, this is actually redshifted. but it's close enough to 21 centimeters, and I can say, okay, obviously this is a 21 centimeter line, which has shifted a little bit. Now, using this mean that I calculated, I am able to figure out how much that shift is, and then find out the velocity of the source.
Okay. Okay.
If there are a bunch of lines, then for each line, I can do this one by one, and I can figure it out. The issue comes when there's lots of lines in the same area, and you don't know which line is where. But that is very, very rare.
How is it that we get data that is not in the photographic form? Such as the LIGO has, I remember reading LIGO has created a map of the gravitational field and so on. So gravity is not something that is visible. How is it that we get data out of it?
Okay, right. So for each kind of observable, we have an instrument. So for visible light, we have our telescopes. For radio, we have our radio antennae, the huge big ones you will see. For example, the Arecibo one, which broke recently, the GMRT ones we have in India. So these are instruments specialized for radio telescopes. Similarly, LIGO and Virgo are instruments specialized for measuring gravitational waves. So it comes out to the same basic thing. If you're measuring thing at two antennae in radio telescope, using that you can create a map of the sky. Similarly, if you have multiple gravitational wave observatories, you can use a similar procedure to create a map of the sky. I'm not exactly sure about what LIGO and Virgo exactly did. I haven't looked into that much. But from my limited knowledge, I have some knowledge about radio astronomy and a little bit about visible as well. And from my knowledge, it should not be the theoretical part is pretty much the same in both places. Any other questions? Yeah, you can ask me anything, by the way. It doesn't have to be related to the session. Lots of people ask me things quite unrelated. I'm happy to answer. If you have any questions, you can ask me now.
How exhausting is it to work on the data, to work on the astronomical data that is so fine and elaborate all the day?
I didn't get your question.
I was asking how exhausting is it to work on the such fine data?
Exhausting as in like physically tiring?
Yeah, yeah.
I mean, however fine the data is, the thing is that your code will be the same, right? You just have to change the number of points, something, and like the code will take a longer time to run if the data is more fine. The data is finer, it will take more time to run, but for us, it is almost the same. The better the data is, the lesser the errors will be. That's the big advantage. Okay, it's past 1 now. If there are no other questions, I'll stop. If there's anything else, I'm ready to stay for a little while more.
Excuse me.
Yes.
Can we predict the positions of these like stars and stuff using just the 2D picture which we got?
Not a 2D picture. If I have multiple 2D pictures at different frequencies, which is basically a 3D picture, if you think about it. So then I can figure out, using the Doppler shift, I can figure out velocities. Actually, only radial velocities. I don't get much information about tangential velocities. But with the radial velocities alone, I am able to figure out quite a bit of the motion. Sometimes you can make some simplifying assumptions, and you can also find out the tangential velocities. Like if you have a galaxy, you can find out radial velocity of every star within the galaxy, and you can assume it is moving in a circle around the galaxy, and that will give you the tangential velocity as well.
Approximate, right?
Approximate. You can make simplifying assumptions, which will give you approximate results.
Oh, nice.
Anyways, on small time scales, these things aren't changing much, right?
Yes, yes.
So how do you convert an image which is taken, suppose in radio frequencies, to something that we can see?
See, when taken in radio frequencies, once again, it is just a 2D image with numbers at every position, right?
Yes.
Now we can assign a color to each of these numbers, and we can look at it. See, a lot of the images that you see on the internet, almost all of them have fake color. This is also fake color. This was originally a black and white image. It just has a grayscale value at every point in a 800 by 800 grid, right?
Okay.
So even in radio, it's just the signal strength at each point. And if you want, you can assign a color to each.
Okay, okay.
It's still being recorded now. It's recording. Okay, I've stopped sharing. If you have more questions, keep asking. Otherwise, I guess you can leave. Thanks a lot for attending. I hope you enjoyed.